Hello everyone. Now we shall discuss few important concepts on inverse trigonometric functions. Inverse trigonometric functions contains 1 mark question, 1 mark question, 2 marks question and 3 mark question. So basically that 1 mark question is usually on domain and ranges of 6 inverse trigonometric functions. The ranges are also called as principal branches. So first of all we shall discuss domain of these functions. So for sine inverse and cos inverse, domain will be closed interval -1 to 1, and for cosec inverse and sec inverse it will be r minus open interval -1 to 1. For tan inverse and cot inverse it's r to r. Here you need to realize that sine inverse, cos inverse of one kind, cosec inverse, sec inverse of one kind, and tan inverse and cot inverse of one kind. But for ranges or principal branches, you need to separate this sine inverse, tan inverse and cosec inverse, because basically it contains minus pi by 2 to pi by 2. So for sine inverse it will be closed interval minus pi by 2 to pi by 2, and for tan inverse it is open interval minus pi by 2 to pi by 2, and for cosec inverse it is closed interval minus pi by 2 to pi by 2 minus the middle element. From minus pi by 2 to pi by 2 we have 0. Similarly, you need to split the other terms as cos inverse and sec inverse, and another one will be cot inverse. You need to consider these three. For this, usually it is 0 to pi, but for cos inverse you need to consider closed interval, and for cot inverse you need to consider open interval, and for sec inverse you need to consider open interval 0 to pi minus the middle element will be pi by 2, therefore singleton pi by 2. Usually one question on 1 mark will be on this particular part. So otherwise 1 mark question may be on the concept of find values of principal value of cot inverse of -1 by root 3 or sine inverse of 1 by root 2, like this. So here we can consider cot inverse of minus theta is equals to pi minus cot inverse of theta. So basically we have sine inverse of minus theta is minus sine inverse of theta, and tan inverse of minus theta is minus tan inverse of theta, and cosec inverse of minus theta is minus cosec inverse of theta, and for cos inverse, sec inverse and cot inverse it will be pi minus of that. So here cot inverse of minus theta is pi minus cot inverse of 1 by root 3, that is cot inverse of theta. So which is equals to pi minus cot inverse of 1 by root 3 is pi divided by 3, which is equals to 3 will be LCM, 3 pi minus pi will be 2 pi by 3. This is the principal value of cot inverse of 1 by root 3. Similarly, tan inverse of minus root 3. So how we can find tan inverse of minus root 3? Tan inverse of minus theta is minus of tan inverse of theta, therefore tan inverse of root 3 we have here. Therefore this is minus of what is tan inverse of root 3? So it will be pi divided by 3, therefore the answer will be pi by 3. So next we may have some problems like simplify the given function. So here we have one tan inverse of cos x minus sin x divided by cos x plus sin x. Whenever you have the terms like this, your intention must be to make this position 1. So how can you make this position 1? Multiply numerator and denominator, or divide numerator and denominator by cos x, then it is cos x by cos x 1 minus sin x by cos x will be tan x divided by 1 plus tan x, so that this is equals to tan inverse of pi by 4 minus x, because 1 is tan pi by 4, therefore tan inverse of tan of pi by 4 minus x. So tan inverse tan get cancels, pi by 4 minus x. So in differentiation also you may have the problems like this, but you need to find the derivative of this function. Derivative of this function will be minus 1. So here also we need to simplify the given function. Since you have square root of 1 plus x square, we know the formula for 1 plus tan square of theta, therefore substitute x is equals to tan theta. For substituting x is equals to tan theta, you have 1 marks in scheme of evaluation. Here we can write it as tan inverse of square root of 1 plus tan square theta will be sec theta, because square root of sec square theta it is. So minus 1 divided by tan theta. Now we need to simplify it further. This is tan inverse of sec theta will be 1 by cos theta minus 1 divided by sin theta by cos theta, so that we can cancel this cos theta and this cos theta by taking that cos theta in the numerator as LCM. Therefore, if cos theta is LCM, 1 minus cos theta it is divided by sin theta. To convert it into standard form, we need to write it as tan inverse of 1 minus cos theta will be 2 sin square theta by 2. Sin theta will be 2 sin theta by 2 into cos theta by 2. Therefore, you can cancel 2 and 2, sin square theta and sin theta by 2. Therefore, it will be sin theta by 2 upon cos theta by 2, which is tan inverse of tan theta by 2. So, which is equals to theta by 2. But what is theta? So, for our substitution, this theta is tan inverse of x. Therefore, it is tan inverse of x divided by 2. This is one of the important problems. Either this may be asked in this inverse trigonometry, or this problem may be asked in finding the derivative of this function. And here also we have two important results. So same result on left hand side, but the right hand side is different because the domain is different. So one is minus 1 by root 2 to 1 by root 2, and another time 1 by root 2 to 1. You should look at this required result. So if you need sin inverse of x, then you need to substitute x is equals to sin theta on the left hand side. If you need cos inverse of x on the right hand side, you need to substitute x is equals to cos theta. Then left hand side will be here. Particularly I will consider this first one here. Then it will be sin inverse of 2 sin theta into square root of 1 minus sin square theta is cos theta. Therefore 2 sin theta into cos theta it is, which is equals to sin inverse of sin 2 theta, which is equals to 2 theta, which is equals to theta is what? 2 sin inverse of x. In the same manner, by substituting x is equals to cos theta, in the final step we will get 2 cos inverse of x. Same left hand side, but the right hand side is different because the domain is different. Then we may have simplified form of another function, that is tan inverse of cos x divided by 1 minus sin x. So how can we prove this one? So simplify this one. So cos x can be rewritten as cos square x by 2 minus sin square x by 2. One can be written as sin square x by 2 plus cos square x by 2 minus sin x. So this is equals to, numerator is tan inverse of cos square x by 2 minus sin square x by 2 is cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2. So in here this sin x can be written as 2 sin x by 2 into cos x by, this denominator is nothing but cos x by 2 minus sin x by 2 the whole square. Why I am considering this as cos x by 2 minus sin x by 2 whole square means here x is minus 3 pi by 2 to pi by 2. Therefore, that x by 2 will be minus 3 pi by 4 to pi by 4. There cos x by 2 is greater than sin x by 2. Now we can cancel this square and this. It is cos x by 2 plus sin x by 2 divided by that. So again the same concept, I will make this position 1 by dividing numerator and denominator by cos x by 2. Then it is 1 plus tan x by 2 divided by 1 minus tan x by 2, which is equals to tan inverse of tan of pi by 4 plus x by 2. Therefore, tan inverse and tan get cancels. We get pi by 4 plus x by 2. So this is also one of the important problems in inverse trigonometric functions, that is two functions in terms of tan inverse will given, you need to prove it as one function. So here we need to use the formula tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y divided by 1 minus xy. Comparing here, we get x is equals to 1 by 2, y is equals to 2 by 11. So 1 by 2 plus 2 by 11 divided by 1 minus 1 by 2 into 2 by 11. By simplifying this one, we get tan inverse of 3 by 4. So we may have another problem like this, tan inverse of this and tan inverse of this. This is bit different. 2 tan inverse of 1 by 2. Actually, 2 tan inverse of x is equals to tan inverse of 2x divided by 1 minus x square. Therefore, 2 tan inverse of 1 by 2 will be equals to tan inverse of 2 into 1 by 2 divided by 1 minus x square means 1 by 4, which is equals to tan inverse of numerator will be 1 and the denominator will be 3 by 4. Otherwise, we can write it as 4 by 3. Now we need to consider tan inverse of 4 by 3, tan inverse of 4 by 3 plus tan inverse of 1 by 7, which is equals to tan inverse of 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. If you simplify this one, you will get tan inverse of 31 divided by 17. So this is also find the simplest form of one of the important problems. So here cot inverse of 1 divided by square root of x square minus 1. We know that we have a formula for secant square theta minus 1, that is 1 plus tan square of theta is equals to secant square theta, means tan square of theta will be secant square theta minus 1. Therefore, here by substituting that, we get cot inverse of 1 divided by tan theta. So it will be cot inverse of cot theta, which is equals to theta. So we have substituted x is equals to sec theta, means theta will be sec inverse of x. The same problem may be asked in different form, that is tan inverse of 1 divided by square root of x square minus 1 also. There you need to substitute x is equals to cosec theta. So here also I have mentioned very few important problems. So I will give the hints. I don't go to solve these problems. I will give you the hints. Here sin inverse of 2x divided by 1 plus x square means, which is 2 tan inverse of x. This is 2 tan inverse of y. We can take 2 outside. Therefore, this 2, that 2 get cancels. You will remain with tan inverse of x plus y. One second, x plus y divided by 1 minus xy, because it is tan inverse of x plus tan inverse of y, which is x plus tan inverse of x plus y divided by 1 minus xy. Finally, it will be x plus y divided by 1 minus xy. So in the question number 14, sin can be shifted into right hand side, then it will be sin inverse of 1. So if it is sin inverse of 1, sin inverse of 1 is pi by 2. Sin inverse of x plus cos inverse of x is equals to pi by 2. Therefore, in place of x, you should have 1 by 2 to get that pi by 2. Question number 15 is very important problem. So there again you need to use tan inverse of x plus tan inverse of y form, that is tan inverse of x plus y divided by 1 minus of x minus 1 divided by x minus 2 into x plus 1 divided by x plus 2 is equals to pi by 4. Otherwise, you can take the tan inverse into right hand side. Tan pi by 4 will be 1. Here you need to take x minus 2 into x plus 2 LCM, and you need to simplify. Finally, you will get plus or minus 1 by root 2 as the answer. Again, many students will write the question number 16th answer as 2 pi by 3, but it is not 2 pi by 3, because 2 pi by 3 means 2 into 180 divided by 3, which is equals to 3 ones are 3, 6 is so 120. 120 is not the principal branch for sin inverse. Therefore, how can you find this one? So you can consider sin inverse of sin 2 pi by 3. Sin inverse of sin 2 pi by 3 will be sine of pi minus 2 pi by 3, because sine of pi minus theta is sine theta. Therefore this is sine inverse of sine of 3 will be LCM, so 3 pi minus 2 pi will be pi by 3. Pi by 3 means we know that 60 degree. Now you can cancel the sine inverse and sine to get the answer as pi by 3. So you may ask with simple problems like this sine of pi by 3 minus sine inverse of this. So sine of pi by 3 as it is, sine inverse of minus theta is minus of sine inverse theta. So minus of minus you can take outside, it will be plus. So sine inverse of 1 by 2. Sine inverse of 1 by 2 will be pi by 6. So you have pi by 3 plus pi by 6, which is 60 plus 30, which is equals to 90. Sine of pi by 2. Sine pi by 2 is equals to 1. The answer will be 1. Similarly, you have tan inverse of root 3 minus cot inverse of minus root 3. This is also one of the important problems. So tan inverse of root 3 will be pi by 3 minus, here cot inverse of minus theta is pi minus cot inverse of theta. So cot inverse of root 3, therefore it is pi by 3 minus pi minus cot inverse of root 3 will be equals to pi by 6. Therefore it will be pi by 3 plus pi by 6 minus pi. Therefore the answer will be minus of pi by 2. So this is one more kind of problem. Write the simplest form. Again, as I said, if you have numerator and denominator term, you should make this position 1. So here it will be tan inverse of dividing throughout by b cos x. Numerator will be a by b minus b get cancelled, sin x by cos x remain with tan x divided by, this is 1 plus, so here again dividing by b cos x, it will be a by b into tan x. So this is tan inverse of a by b minus tan inverse of tan x. So that this is tan inverse of a by b minus x will be the final answer. So this is one more kind of problem. Tan inverse of 2x plus tan inverse of 3x is equals to pi by 4. Find the value for x. So here first of all tan inverse of x plus tan inverse of y form. So by applying this we get 5x divided by 1 minus x square is equals to pi by 4. Shift this tan inverse into right hand side, then it will be 1. Therefore 6x square plus 5x minus 1 is equals to 0. Therefore factorizing it we get x is equals to 1 by 6 or x is equals to minus 1. But if you substitute x is equals to minus 1, left hand side will be tan inverse of minus 2 plus tan inverse of minus 3. It will be negative, but right hand side is positive. Therefore x is equals to 1 by 6 is the only solution for this particular problem.